Devices can now be charged without cables. When the back cover of a phone containing an LED is placed on the charger, it flashes. When an LED is placed on an induction heater, it also flashes. This video explains how wireless chargers transmit electrical energy. This charger needs no cable. In order to find out how it works, let's disassemble a smartphone and connect an LED to a circuit on the back cover. This large black plate. When the cover is placed on the charger, the LED flashes. What's inside this black package? It's a coil. You may know that coils and magnets can be used to generate electrical power. Thus, the charger must contain a magnet. Let's remove the cover. What's this? Another coil. This may seem strange, but hold on a moment. A coil becomes an electromagnet when an electric current flows through it. Thus, this pair of coils can generate electricity. Let's connect a battery to the coil, making it function as a magnet. Hey, the LED isn't flashing. In fact, there is a big difference between these two coils. Do you know what it is? The answer is whether the current is direct or alternating. We need to move the magnet to generate electricity from the coil. Watch carefully. The indicator on the ammeter moves only when the magnet moves. A battery-powered coil becomes a magnet, but it remains at rest. It doesn't generate electricity. However, the charger is supplied with alternating current, whose polarity changes rapidly. Accordingly, the north-south direction of the induced magnet changes quickly, like a rotating magnet. This is how a wireless charger supplied with AC electricity creates a rotating magnet and induces an electric current in a smartphone without a cable. In the same way, let's replace the dry battery in the handmade coil with an AC electric source and bring the other coil close to it. Look, the LED is flashing as intended. This mechanism is also used in induction heaters in the kitchen. Place the coil on an induction heater. Look, the LED is flashing. Induction heaters contain AC-powered coils, which act as rotating magnets and deliver energy to specially made cookware. Now you can understand this mechanism. Sending energy to remote targets is very important in materials research. This is a furnace used to make metallic alloys containing suspended molten metal. If we were to melt it in a crucible, the walls of the crucible would contaminate it. That's why we suspended the metal using a special technique. How can you heat a material without touching it? Yes, you can do so by using the technique we've learned about. The furnace contains a coil which receives a high-frequency alternating current whose polarity changes very quickly. This coil acts as a rotating magnet and transmits energy to the suspended metal. When magnets are paired with electricity, they are very useful in sending energy to remote targets.